Hey guys, welcome back to another section. In this section, we are going to talk about networking in Docker. Now, in this section, what we are going to discuss about what Docker provides us is several network options to facilitate communication between containers and the external world. These networking options allows you to configure how container communicates with each other and also with the host system. And we'll also be looking at how it connects externally. So the first one we are going to talk about is the bridge network. So this is the default network type in the Docker. So if you're not going to give -- network or -net equal to something, this is what you're gonna get by default. The containers which uses this kind of a bridge network uses the communication pattern in which that it communicates with a different IP address which is given to it when the containers are created. Now, Docker creates a virtual Ethernet bridge called Docker 0 on the host, and each container which is getting connected through this bridge network will be utilizing that particular Docker 0 Ethernet and the range which is given as a subnet for that. So we will discuss more in detail. I'll just show you. I have an architecture. When we go forward on the bridge network, I'll show it to you. It's much more easier to explain it in that way. In terms of a real-time usage, like in which situation would we use a bridge network? Running multiple applications on a single host that needs to communicate with each other. And also especially when you want to run applications with the same port number without modifying the default configuration, this is the best way to use. This is the best networking to use. The next one we are going to talk about is a host network. When a container is run with -- network equal to host, which means that you need to specify explicitly to make sure that your container starts with a node host network. It uses the network namespace of the host system, which means that you're not going to use the Docker 0 like we said before in terms of bridge, which means that it's going to use whatever the IP address which is currently assigned on your host machine where you're hosting your container, and it's going to use that IP address. So which means that when you are running Nginx or Apache or any kind of a software which is dependent on a port number, that's going to be a problematic, because you may need to customize a port number when you start these processes, because as we are running this on VAS host 1, so it's going to use the same IP address. If I have multiple containers created, I cannot create with the same port number because the IP address is going to be same for all of these containers, and that's going to be a problem if you're going to use the same port number. Overlay network is to enable communication between container running on a different Docker host. For example, you have two Docker hosts running, so VAS node 1, VAS node 2, both of them are running multiple containers, and the node 1 and node 2 want to communicate, as in like between the Docker machines within that container machine needs to communicate. So you need an overlay network for that. This is useful when you are using a Docker Swarm or Kubernetes cluster where containers may be running on multiple nodes wants to communicate with each other. So the use case for this in this scenario is going to be deploying containers across multiple Docker hosts, like for an example, Docker Swarm or Kubernetes cluster. The next one is the MAC VLAN. MAC VLAN network allows containers to have their own MAC address and appears to be as a physical device on the network. This is useful when you need to assign IP address to a container directly from the subnet of a physical network. Containers on MAC VLAN network can communicate with each other devices on the network as they were like a physical server. In terms of use cases, running containers that need to appear as a physical devices on have its own MAC address. So in that situation, you can use this. For example, running a container that requires direct access to physical network, such as Internet of Things, devices, or network appliances, where each container requires a unique MAC address and IP address. In those situations, MAC VLAN network would be preferred. Another one is non-network. Non-network tells you that it's going to be not on network, so which means that you cannot actually communicate with the external network, or within Docker to Docker or container to container communication also won't be available. So this kind of network will be chosen when you are giving -- network equal to none. So this can be useful for creating isolated containers for testing purpose, or for containers that doesn't require network access. In terms of the last one, which we are going to talk about, is custom network. Docker also allows you to create a custom bridge network with using your user-defined subnet, IP address range, and other configuration. Custom network provides more control over the network settings and can be useful for organizing containers into logical groups or isolated from other containers. These network options offers flexibility and allows you to choose more suitable networking configurations for your Docker environment. And I have also discussed most of the use cases. So if you have any questions, please reach out to me. You know how to connect with me. In the next video, we will go in depth about each of these networks and then try to understand a little bit about it. In case if it's like something which is relevant to your training program, I will be working on architecture, as well as I will be showing you hands-on as well. So most of them is covered actually. Thank you again for watching this video. I will see you in the next one.